All right, this is going to be a quick explanation of what confidence intervals are really all about. So presume that we have a population. I'm going to sample them about some sort of yes-no type question or a simple binary choice type question, and about 50% of them feel one way versus the other. And let's say that I've taken a sample, I find about 60% in my sample, that's that little red or blue X right there, and I've created a 95% confidence interval, and my sample size was 30 people. So if I take different samples, I will get different confidence intervals. And most of the time, I will capture the true mean. In fact, sometimes I will miss it, but most of the time, I'll catch it. Now, to see this in action, let's do several confidence intervals at the 95% level. So let's do 5. And here I've got 5 confidence intervals from the same population. Each one of these little X's in the middle here, boom, 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 those guys. Those are my actual proportions that I measured. I create the 95% confidence intervals, and one of my intervals missed the actual average. Now if I do 5 more, I might catch them all. If I do 5 more, I might miss one again. And on we go. So let's say, what if I did a bunch of these? Let's do 20 confidence intervals. So I take 20 different samples, all of size 30. One of my confidence intervals missed. These are all 95% confidence intervals. And look at this, I'm 95% confident. If I do it again, one of them missed. Ooh, now many of them missed. This is entirely possible. Now all of them hit. Now a couple of them. Now I'm 90%, 90, 90, 85, 100, 100. In the long run, it should be that 95% of your confidence intervals actually capture the true mean. So let's do lots of them. Here are 50 confidence intervals. And I've got 96, 98, 86, many of them actually capturing. What if I did 100? Now you can see that if I do more and more and more confidence intervals, I have about 95% of them capturing the true mean. Now, if I'm going to take this back to 10. Now, if I change my confidence level, let's change it from 95% to 90%, I should miss a bit more often. Let's do 100 of them here. Only about 90% of my confidence intervals should capture the true mean. If I change my confidence level to something significantly smaller, like 68%, now most of them, well, not most of them, about 68% of them should miss. On the other hand, if I go 99%, notice that my confidence intervals are now really wide, but most of them are capturing the true mean, the vast majority. Now if I take my sample size to be larger, I have a much tighter confidence interval, but still, on a 99% confidence level, I'm still capturing the true mean 99% of the time. If I make my sample size even bigger, so now I've got a sample size of 100, my confidence intervals get narrower, but I'm still capturing the true mean 99% of the time. If I take my sample size to be 1,000, now it's really small, but I'm capturing it 99% of the time with 99% confidence interval. This is still going to be true if I have a 95% confidence interval. I'm going to capture it about 95% of the time. Now if I go the other way and make my sample size real small, my confidence interval gets real wide, but I'm still capturing the true mean about 95% of the time. So, going back to the basics, if I have one confidence interval, I may miss the true mean. But if it's 95% confidence, I should capture the true mean in 95% of my confidence intervals. If the sample size increases, the size of my confidence interval should decrease. So now if I'm taking samples of size 1000, I've got this tiny little confidence interval, but it's still capturing the mean 95% of the time. I hope this has helped to clarify what a confidence interval is all about.